start with this molecule. Let's number the carbons just to keep track. Like that. And then what we're going to do is we are going to treat this with a catalytic amount of acid, and we're going to add a dehydrating agent, magnesium sulfate. So if you see magnesium sulfate in these kinds of problems, think about an agent that is able to remove any water that might be formed. So we have a carbonyl group. Again, let's highlight the carbonyl carbon. We also have two alcohol groups. And so this is an interesting scenario. Write the product if you can. A good way to get started if you didn't get to the product yet is to think about the acetal that would form. The acetal that would form would have a new bond between this oxygen and this carbon, and a new bond between that oxygen and the carbonyl carbon. And remember, we're going to lose overall a molecule of water as well. So see if that helps you write the product. It might be helpful to also number the oxygen. So I guess I'll have to number this number 0. And then let me call this number 8. So we're going to form a ring here. The ring is going to have 1, 2, 3, 4, 5 atoms in it. And then over here I'm going to form a second ring with 1, 2, 3, 4, 5 atoms in it. So see if that helps you write the product if you don't have the product already. Here's the carbonyl carbon, or the former carbonyl carbon, number 4. And then there's a 5-membered ring in which that carbon is involved. And then there's another 5-membered ring within which that carbon is involved. And then we just have to make sure we've got all the right stuff attached. So here's carbon 3, carbon 2, carbon 1, carbon 5, carbon 6, carbon 7. And then right here there's an oxygen. And then right here there's an oxygen as well. So there is the acetal that has formed. Notice it's an interesting structure where you have two rings that share just one carbon in common. That would be the structure of the acetal in this particular problem.